Okay, hello everyone. I hope you are doing great. So we are doing one of the question that is a three sum street code problem. Okay, so this is the problem that we will going to be solved today. And okay, so I hope you are able to you are able to see my screen and you can see this. So this is a three sum lead code problem. So it's a kind of basically a array type of problem. So what it is saying that you will be given an integer num array, you will be given an integer array that is a num, and you have to return all the triplets such that nums of I, nums of j, and nums of k is equals to 0. Okay, you have to do this, and one of the cases that your I, j, and k should be unique. Okay, now the another question is another that is a notice that the solution which you are providing, it should not contain the duplicate triplet. Okay, we'll see how you can see this, and we will see one by one. Okay, so let's say I have this particular a minus 1 0 and 1 2 minus 1 4. Okay, so now let's say this is my one of the array and I have to return all the triplets basically that sum is equals to 0. Okay, so what the simpler approach, what will be the brute force? So we will first go with the brute force approach, and we will see that how the brute force approach is, and how we can do it in the brute force approach. Okay, so simply in the brute force approach, what we can do, we can just use three, basically we can just iterate, we can just use three loops. So one is I is less than, that is a nums dot length minus 2 and I plus plus. Okay, now for j equals to 0, j is less than nums dot length minus 1 j plus plus, and there will be this j will be equals to I plus 1, and for k what I will do, j plus 1, j is less than nums and j plus plus, and here I will check if, here I will check if my a of I plus a of j plus a of k equals to 0. If it is 0, then I will insert it in the my resultant list. Okay, now I also have to maintain, basically I also have to sort this one. So I will sort the result here, sort my triplet, and then I will push it in the set. Why I'm pushing it in the set? So that I do not get any duplicate element. Okay, so that's why I'm pushing the set, and then I can, at last I can basically return the result. So why I need to sort the array, so that I would get a unique element, unique triplet always, and if I put it in the set, then it will be unique. Okay, so we will see that what is the time complexity. So the time complexity would be, I am iterating through three loops. Okay, so basically what I'm doing, hmm, big of n cube. Okay, so for every one, what we are doing, uh, we are pushing it into the array. So what you can say that big of n plus log of m times. Okay, so we are iterating, we are using three loop, and these three loop all are together, and so it will be big of n cube, and we are using set, so it will be big of log m. So for inserting the element in the set, and we are saying that m is the number of unique triplets that I can have. Okay, okay, so now the space complexity will be my big of because the extra space that I'm taking for storing the triplets. Okay, now we will see how we can do it with a better approach, because this is a brute force approach and it's a simpler approach. We are just looping through three for loop, and you are just checking if a of I plus a of j plus a of k is equals to 0 or not. Okay, so we will see one of the approach. Let me just provide you an array. Okay, this will be my array. Let's say these elements are something like minus 2 minus 2 minus 1 minus 1. This will be 0 0 0 2 2 2. Okay, so what I have done this, I have first shorted the arrow. So this is not the exact array, I have the shorted array. So first I will do, I will short the array. So this is my, basically this is the problem. So let me just show you. Okay, so this particular problem, this particular answer is a two pointer solution. Okay, two pointer solution. So we will see what we are doing here. So we have first sorted the array, and for ith element. So for, let's say my I is here, I'm maintaining two pointer. One is my low pointer and one is my high pointer. Okay, this is my high pointer that is pointing to high element. This is my low pointer that is pointing to the low element. Okay, so what I am doing, I know that a plus b plus c equals to 0. I have to do this. Okay, now this is my this element I am taking as a constant. So a will be my minus 2. Okay, so this particular ith element will be my a. Okay, so what I have to do, b plus c is equals to 0 minus a, that will equals to minus a. So what we can see that, so my b plus c should be equals to 0 minus minus 2, that equals to 2. So it means that I have to basically get that element where my low plus high equals to 2. Basically a of low plus a of high is equals to 2. Okay, so we'll see how we can do this. Okay, so what we have to do first, so for example my ith is here. Okay, ith is here, so my low pointer is here and my high pointer is here. Okay, so I will just check. Minus 2 plus 2 is equals to 0. Yes. 0 is equals to 2. No. 0 is less than 2. Yes. If 0 is less than 2, it means that I have to increase my result. How can I increase my result? If I increase my low pointer. Okay, so what I will do, I will just put my low here. Okay, now I'm here. Now where I will do? Minus 1 plus 2, that is equals to 1. Okay, it is 1. 1 is less than 2. It means that I again have to increase my low pointer. My low pointer will be higher. Okay, now it will be 0 plus 2 equals to 2. Yeah, I got the answer. My 2 is equals to 2. It means that I got the answer. Okay, so what I will do, I will just put it in the array list, my resultant list. So what it will be, minus 2, that in my ith element, the value at low pointer and the value at high pointer. Okay, once I do that, I just increase the low by 1 and the high by 1. I've increased the low by 1 and high I have decreased by 1. Okay, now now, one point that we need to basically notice here is that, so we already have calculated the value for this particular 0, right? Because this one was 0, so we have already calculated. Now, if we'll again do this for this 0, we are again getting the element that is minus 202. So that is just a duplicate element, okay? And we in the question it was written that we do not need to basically the set should not contain a duplicate element, okay? So what I can do is that I will go till I do not get any element that is not equals to my previous element. So here you can see this 0 is these two values are equal. Yes, I just move my high here. These two values are equal. Yes, I will move my high low here. Okay, these two values are not equal, so I my low pointer will be here. Okay, similarly we will do for the same for high. This 2 is equals to 2. Yes, I will decrease my high. This 2 equals to 2. Yes, I'll decrease. Now this 2 is equals to 2. Yes, so now what we can see that my low is less than high, so I will just break the loop. So for this particular ith index I got a triplet as a minus 202. Okay, now we will see one more example that how we can do that. Okay, now one more thing that we need to notice is that my I is here. Okay, so should I consider this one also? I should not consider this one also, because I should not consider this. Why? Because I have already calculated a triplet with this minus 2. So again, this is minus 2. There is no point to again calculating the triplet because it will give me the duplicate element. So there is no point. So I will move till I do not get any element that is not equals to the previous one. So I will go with this one. Okay. Now we'll see that how we can go. Let's see one more. Let's go with one more element. Okay. Minus 2, minus 2, 1, minus 2, minus 2, minus 1, minus 1, okay, minus 1, 0, 0, 0, 2, 2, 2. Okay, so this one. Okay, now my ith was here. Okay, let me just use it. Okay, my ith is here and my low pointer will be here and my high pointer will be again here. Okay, no, I will again do that. So it will be constant, so b plus c, that should be equals to my 0 minus minus 1, it should be equals to 1. Okay, so now I will check low plus high. Minus 1 plus 2 is equals to 1. 1 is equals to 1. Okay, it means that I got the element. So my triplet will be minus 1, minus 1, comma 2. Okay, this will be my one triplet. I can move this one, low pointer by 1, high pointer by 1. Okay, now there's no point in calculating the value for this minus 1 because we have already calculated this. So I will move till I do not get any element that is not equal to the previous one. So this one, I have just moved it. Okay, my low is here. For 2, I will again just do this for this 2. Okay, now I will again do 0 plus 0 equals to 0. Is 0 less than 1? Yes, so it means I have to do this. 0 is less than 0? Yes, I have to again do. Now my low pointer moves here. So my low pointer moves here and L is less than H. So I will just break the loop. So for this I got a triplet that is minus 1, 2. Okay. So this one, how we can do this. Okay. So now we will see the time complexity and the space complexity that we are taking. Okay. So let's see the time complexity. So the time complexity would be big of n. So we are iterating the whole array. So you can see that I is iterating the whole array. So it will be big of n. And for the rest element, so for every I, we are iterating to the right half of the array. Basically, we are iterating the right part of the array. So that is equals to low is iterating this much, high is iterating this much. This is low, this is high, and it's equivalent to n. So we can say that big of n, or it will be equals to big of n square. Okay. The space complexity is we are not taking any extra space. It will be big of 1. Okay. So we are just taking an extra space for storing the result. So that is expected in the question that you need to basically store the element in an array and you can return that. So that will not be considered. We are not taking any extra space other than the one that is used for storing the result set. Okay. Now we'll see that how we can do basically. Let's see the Java code and how we can do that. Okay. Let me see the Java code for you. Okay, so this is the Java code for that. Okay, so the first thing that we have to do is that we have to sort the array. We have to sort the array, and once I have sorted the array, I have just declared a resultant, basically a list that will be a list of list. Okay, now I'm iterating from I0 to nums dot length minus 2. So I'm iterating to the third last element of the array. So basically, because that will be the my only last triplet. Ahead of that, there will not be any triplet. Okay, so what I'm doing that for if I equals to 0 and or if I is greater than 0, and so I will tell you why I'm doing this. What I'm saying is that, so if I just show you here in my previous one, okay, you can see here is that you can see that for minus 2 I have already calculated the value. Okay, now for minus 2 I have already calculated the value, so there is no point to calculate this one because it will again give me the same result and it will be a duplicate one. So I have to just ignore this one and I will move till I do not get any element that is not equal to the previous one. So that's what I'm doing here. Okay, so I'm saying that if I is greater than 0, I'm checking if nums of I does not equal to nums of I minus 1, because for that I have already calculated the value. Okay, and for I equals to 0 I have to do anyway because that is the first time I'm doing. Okay, I'm declaring three variables. One is the low, that is my I plus 1, high, that will be my nums dot length minus 1, and the sum that will be equals to my 0th minus nums of I. So basically whatever the ith element, I'm just basically my sum will be 0 minus nums of I. Okay, now I have to do that. A of low plus A of high is equals to my sum. It should be that. Okay, now I'm iterating till low is less than I. Okay, so I'm checking if my nums of low plus nums of high is equal to sum. It means that I got the element, I got a triplet. So what I'm doing, I'm just basically inserting that triplet into my resultant array list. Okay, so I'm doing result dot add and I'm just creating an array list with nums of high, nums of low, and nums of high. These three value will be inserted into my resultant list. Okay, now, what I'm doing here is that I'm checking that if low is less than high and nums of low is equals to nums of low plus 1. So what we are doing here, what we are trying to do here is that, let's say I got the answer with this value minus 1. I got the answer with this value minus 1. So there is no point to calculate again for this minus 1. Okay, because it will give me the same result and it will give me the duplicate basically result. So there is no point to do this. So what I can do, what I have to do is that I have to skip this minus 1. So I have to skip till I do not get any element which is not equals to the previous one. So that's what I'm doing here. What I'm doing is that nums of low equals to agar if these two values are equal, nums of low and nums of low plus 1, if these two values are equal, I just incrementing it by 1. It will increment till I do not get any element which is not equals to the previous one. Okay, same I am doing for the high, that if I for that my high, if it is equals to, if these two values are equal, then I am just decrementing I. So till I do not get any element that is not equals. Okay, I'm just increment the low by 1 and the high minus 1. Okay, by 1. Now, if I do not get any element, if my sum is not equal, if my nums of low and nums of high is not equals to sum, what I'm doing here is that I'm saying that if it is less than sum, it means that it is less than sum. I have to increase the low. So I'm incrementing the low by 1. If it is greater than sum, I have to decrease my high. So I'm decrementing my high by 1. Okay. So once this basically loops, once the low greater than high, then I have to stop. It will basically stop, and in the last I can just return the resultant list. So this resultant list will contain the all the unique triplet. It will not contain duplicate triplet, because we have basically we have removed duplicate triplet once from here and one from here. We have removed these duplicate triplet from here. So there's no, so so that was all from my side. I hope you enjoyed this video and you really like the concept. So basically, these are wonderful questions. I really like this type of questions, and I hope you like the video and you enjoyed the video. So please do like, share, and subscribe. Thank you.